Hope you guys are doing well. So, continuing on a journey, today we would be starting with solid principles and we'll see why we need them, and then we'll see the different types of pattern categorization, and we will see a few of them as well today. And we will try to cover all the patterns, but let's see how it goes because the head first design pattern book is what is recommended when you start with design patterns, right? But before starting with design patterns, there are for certain uh, fundamental things that we need to know, like how is the design pattern related to each other, what is the plus point and what are the advantages. So yeah, it's a very good book to start through, and then we will see why and when do we need them. Okay. So before going that, let's understand something called as solid principle, right? Okay. So first, we need to understand the solid principles. Now, what does the solid principle do? Is the solid principle basically this set of five object-oriented design principles. So these are a set of five different object-oriented uh, design principles. Now, what are we achieving is using this, we are basically achieving to write cleaner code, easier, write a code that is easier to maintain, then easier to extend, and easier to test, right? So, whenever you are working in your organization, these are the four major reasons, right? You will be writing code, right? I mean, if you see, first is basically easier to maintain. Is suppose you are adding additional functionalities, right? So these functionalities should be added easily. You shouldn't change the whole code or start debugging the entire code. That is not a very good way of doing. Um, Debugging the entire code to write a new functionality, or if there is any bug, we should be easily to it should be easy enough for us to remove that bug or remove that feature, and not affecting the others, right? So the other is basically we should be able to write cleaner code. For example, so the way to write cleaner code is basically a code that should be very readable, that should be readable in a single glance, that should be easily readable in a single glance. Like we should not spend hours on the code. The other is basically it should be easier to extend that code. When we say extension, this is basically adding new features. If you're adding new features, then it should be the code should be easy enough. Like we shouldn't be worried too much. And the other is basically the code should be easy to test. So test cases are what are going to be very important, right? There are two different types of test cases that we need to do. First is unit testing and so on. So we should be able to test. It should be easy enough to test our code without causing any breakage or without causing any like the main code shouldn't be taken down because of the test processes. For this, we use something called as to write code in this fashion. We use something called as the solid principles, right? So now there is a famous video of Uncle Bob, right, who is teaching about solid principles and the need to write solid principles. Right? You can just go on YouTube, and then you can search for its solid principle video. Solid principle Uncle Bob. If you search for this video, you'll get this one, 6 years old. So this is a very famous video, and um, it's a good way to write a cleaner code and to understand them. Uh, so okay. So now we need to know. So solid is an acronym. So you have this is an acronym, right? So each word in or each letter in this represents a specific thing. For example, S stands for something else. So S represents single responsibility. So S is single response. C single responsibility. O stands for the open close principle. L stands for Liskov substitution. Liskov substitution principle. I stands for interface segregation. This is for interface segregation. And D stands for dependency inversion, right? So this is for dependency inversion. Now we'll see each of them. What does it state? So basically, solid principle enables us. This is like an OOP design feature, enabling us to write object-oriented programming in a much easier and better way. So this is a very important principle that we need to understand, and um, we need to take care of this principle. Uh, uh, okay, no, single responsibility. A single responsibility model or SRPI basically states single responsibility. A single responsibility model or SRP states that each class should only have one function. A class should only have one reason to change. So our class should have only one reason to change. One reason to change. That means so what does it achieve? Is it achieves modularity, and it is basically making our code easier to debug, as it's only having one function, one functionality. We can only, as it is only having one reason to change, what we can do is basically we can just uh, perform that specific function. So let's see. So we will be so like there are many languages that follow OOP or that have so we will be following Java, right? So this is our test.java file. So yeah, let's have this thing. Now let's do class. Okay, so let's have the class test. There is some problem. Oh, what's the problem? The syntax error. Okay, class deleted token. Let's have the class test here. Inside that, I'm going to have my public static void main method. Now this is, I'm going to create new class here. So this is my class. First principle is basically single responsibility single responsibility model. So basically what it's saying is, now you can have multiple instance methods, right? So let's say I'm having a public, let's have a public function defined here, public void, there is no return type, and then let's have a function. This takes in no parameter, and then the only thing that we're doing is this out. we are doing is this is function 1. Okay, now this is one class. So and then what if, so let's see the drawback when we have multiple classes around, like what's the issue with that. So let's have another class, say public void. We are not returning anything, so let's say this is my function 2, and then no, and then let's add and say okay. There is something now illegals. Okay, let's have this properly. Yeah. This is because the object is not created, right? So this is when we are having multiple classes, right? So basically now, right now, this is not this is not following the single responsibility model, right? Because what we have done is we have added two functionalities, right? So this is my function 1, this is function 2, and this is a function 1 run. Now what is SRP trying to solve? Now for example, now why should we separate classes basically? um okay, now let's think of something that is practically happening. Like this is still not a very concrete way to understand, right? So let's see. Now what if we are developing a mail system, right? So like this is our, we need to print the invoice, right? So so we are developing a system. um since we are using class based language, sorry, OOP based language like Java or Python or JavaScript, we'll be using classes a lot there, right? So now what we need to develop is an invoice manager. Now what this invoice manager is going to do is it is going to have three functionalities, right? Basically, first to generate the invoice, second is to save it locally, and third is to send an email. So the first feature is basically to okay, first feature is basically to generate the invoice. uh, the second feature is basically to the second feature is basically to save that invoice to a file, save to a file. And the third feature is basically to send email. First is generate invoice, second is save to a file, third is basically send email, right? Now what if we need to first will be happening this. Now once the invoice is generated, that invoice is going to get passed down to the save to a file method, right? The email will look the from the file and then create an email and then send it, right? Now what if the email system changes? So what if this is changing? Now we need to modify so the entire, first of all, if it's an all in one thing. Now, irrespective of the changes, we need to still modify the whole class, right? Like we will have to come to this class object and then we have to modify, right? What if the file saving logic is going to change? So since it's in the same thing, we are modifying the entire class itself, right? I mean, there is too many changes on one class. So basically, if since we are performing many changes, so there is more problems that we'll run into, right? Accidental bugs are more. Now also, now here we cannot. So if you are trying to reuse, so suppose we inherit this class. By default, this method, and this method will also be included in our inheritance regime, right? Because all the methods will be present there. But then we do not want the other ones to be there. We just want the one that we need so that we can override it and change it, right? Now, beta trusting again. Yeah, so basically that is what is going to happen, right? So I mean, if we even if you see it in the inheritance way, this is not a very good way of, or a very good piece of code, right? Even if we are going to inherit it, suppose we are going to extend this or inherit this class, and then we need to change this functionality. Even these two methods will be present here. But then think of it in a logical way. If while inheriting we cause damage to this generate invoice method, so the subsequent methods are will be of no use, right? Because if a wrong invoice is generated and stored, it doesn't make any sense, right? In that location. So even that is the whole problem why we shouldn't have logic present in one class, because then if you inherit, all will be inherited. And if you change one of the major classes, which is another two are having dependency on these two, right? So if this generates a wrong invoice, then it will be sending a wrong email. Then the whole purpose of us designing a class is gone, right? That is basically what the single responsibility model is doing. Or this the responsibility model states that a class should only have one reason to change. Um, so you can now only have one specific function, or responsibility is like a rule, right? So we are saying single is one. So we are saying that each class should only have one responsibility and one feature. But problem with a server, yeah. So basically, we are going to have more number of classes being present, because single responsibility model is basically going to increase the number of classes, right? But then the thing is, the more classes we have, so the more number of classes we have, that does not mean that we have a very bad code, right? So more number of classes does not mean that our code is bad in any way. So more number of classes does not represent uh, does not indicate that we have written a very bad code. If each class is simple and focused, right? So because that is what the problem is, having a one big class. So big class means you need to debug, or you need to read through all the code, right? That is where we get big problems or big error problems. Now the next thing that we have is basically something called as so next thing that we the next alphabet that we have is O, right? In so solid principles we studied for as. The next thing that we have is basically called as open close principle, right? So the open close principle states that the software entity should be open for extension but closed for modification. Now let's see this. Now let's see what is trying to say here. Because okay, so first is uh, let's write the principle and then we'll see what does it truly mean. And what are we solving? So then is my O. Alphabet O starts for open close principle. Now what does it say? The open close principle says the open close principle says uh, our class should be open for extension, open for extension, and closed for there is open for extension and uh, closed for modification. Now what is this principle trying to say is that means suppose what we want to have develop an additional functionality, right? Suppose we are trying to add something uh, okay, so now let's see the problem, right? So what if we are not paying attention, or like what if we are not using the open close principle? So let's see, this is our code, right? Okay, let's have a notification messenger class. Let's say this is medium. Oh, let's say this is medium. Let's have this thing now. So what if you want to add some? So this is our notification class, right? Now this is still following the single principle because we only have one responsibility here. So S is getting so we are not violating S, we are having S. Now what if here we need to add so this is the email. What if we need to add some other way of reaching a notification, right? So what if we say let's add a way. So this is SMS email. Let's add something like WhatsApp. That means if the person should be notified by a WhatsApp as well. So what if we want to add that functionality? So then we have to check that if we need to add more lines here. So if you are having more line, it will be like we're adding an elif and say if my type is equal to uh, WhatsApp, then we need to do something else, right? So we need to do print sending WhatsApp notification. So basically here is when that so what we have basically done is, even though we added a new feature, but then what we did is we modified this class, right? The main class is getting modified, so we did add a new feature. This is a new feature that is added, but then while adding the new feature, what we have done is we have modified this. So we have modified the original class, right? So then what what the open close principle says is, instead of having this written here like in this format, what you do is you kind of so like these are all messages being sent, right? Either it is sending via email, SMS, or WhatsApp. So what you do is you kind of use the principle of abstraction, right? So what you do is we define a contract. So we define a class that is going to be my abstract class, say notification. And then what we say is inside that we have our abstract methods being written, and we say this is public. This is some access modifier, and then we have it's not returning anything, so I can say it as void, and then function, and then I'm going to do a sys out, right? Okay, we just need to mention the structure, right? So this is some. So what we are saying is there is a function that is present here, and then this is my class which is representing, right? So what we are going to do is we are going to extend this thing to multiple forms, right? So we can have this one being my email. So this is like a contract, right? So whatever class is going to implement this contract, we'll have to implement the other methods as well, right? So this will be like a contract thing that is happening, and then this is like text. So basically what we are saying is whichever a class is going to represent this contract, um, whoever is going to work on this contract will have to take care of all of this, right? So um but then yeah, so what we are doing, so basically we have separated the classes. Each contract is its own working space. That means this will have its own dependencies and whatnot. So if you want to modify this method, or you need to change this, for example, you need to change from Gmail to Yahoo, you just need to make a change to this specific implementing class, right? We do not need to worry about how the SMS or the text is being sent. That is what the open close principle says. That means we should be able to extend our class, but it should be closed for modification. So that means you define a contract and let the class implementing that contract should be able to fulfill all the criteria. Now, the next word that we have is something called as, and that stands for Liskov substitution, right? So let's see. Liskov substitution. The third principle we have is basically something called as a Liskov substitution. Liskov substitution thing, right? So we'll see. Now, what does Liskov substitution says that objects of a superclass should be replaceable with objects of a subclass without breaking without breaking the application. For example, now this is the problem with inheritance that we are trying to solve, right? So for example, we have a bird class. Now a bird can, so this is basically a bird class. So then we can have different types of birds, right? Either it could be a sparrow, it could be an ostrich, any or however it is, and it could be uh, it's an eagle, right? So these are three birds. Those are working, right? Now, what are we trying? So what if we have inside the class we represent a functionality called as fly, right? So not all birds fly. For example, okay, let's see. Let's first write this. This is my ostrich. This is an eagle, and then this is sparrow, right? The fly methods make sense for both, right? For both sparrow, for both sparrow and eagle, the fly method is making sense. But what about ostrich, right? There is no this is not correct, right? I mean, it does not make any sense, logical sense, because ostrich cannot fly. But even though this will be performing inheritance, as we would be inheriting the fly method, inherit. So it's inherit as we would be performing in inheritance. So even the ostrich cannot fly, it will be still having this fly method in it. So that is not a very good way of writing code, right? So what we do is basically you what does Liskov substitution says is um Okay, so what we are trying to solve is now in our code expects all fly, but the ostrich cannot throw an error because ostrich can't fly. Because this is what we have violated is the Liskov substitution. That is what it's trying to say. But why is he? When we are basically making inheritance dangerous, right? We confuse consumers of the class. We introduce bugs when swapping base and derived classes. Okay. The problem is flying is something. So basically, what we're trying to say is, so now the fly method is not possible here, right? So what we should be doing is instead of having this in my base or my parent class, we should use something called as composition, right? For example, what we are doing to do is whichever birds are going to fly. Um, so one the way is basically to you kind of have an first way one would be to solve this is you kind of have a different interface in which you have that method. That is also very proper, right? That is also very logical, right? You have an interface in which you have fly and only the contract or the class implementing this contract should be able to override and change that fly method, right? So that is basically that is very logical, right? Now the other way is basically to use composition or more accurate hierarchy, right? Like but what do you mean by more accurate hierarchy? So what we are doing is basically we are removing that flying bird. Uh, okay, you kind of have a separate class representing this feature. So you take this thing out. Okay, this is one method is you kind of put it in the interface, right? What happened? One was to have an interface and the contracts or the classes that are following this contract is going to implement this. Suppose if my sparrow is going to implement this contract, then it makes sense, right? Implement this fly. Whichever bird is flying, we are just going to implement it. The other alternate way is basically why don't we solve the hierarchy, right? So there is a problem with the hierarchy, right? That means uh, so flying is the feature that is not supported by all birds, right? It's only supported by a type of bird. If that is the case, why should we put that feature in the base class itself? Because remember in inheritance what we are going to do is that base class is what is going to define is what going to be inherited, right? So if the flying is not a feature that is common to all, so basically the whole process of using inheritance is to separating out common principles, right, and then overriding. This is my base class, right? So then why should we have this in the base class? So instead of using inheritance we go something instead of having this base class issue, that means, I mean, this is not getting utilized here. So why should we keep it in the base class itself? Instead is basically you take out it from the base. Instead, what we do is we kind of uh, follow some other principle, right? Basically, we remove it from the base class, and then instead of you remove it from a basic class, and then we kind of use something called as a dependency injection, right? So now what we are going to do is first thing is we are going to take it out of the base. So this is out of the base. That means this will be present in some other class, right? So because it's OOP, right, it has to be present in some class. This is my function fly. This is present in some other class. So let's say um this is my flying bird class. Now but what is going to happen is, so now my but then the other, so if this is a bird, see other features like the name, or for example something called as they'll all birds lay eggs, right? They lay eggs. Then they have certain features, right? They have feathers on them. They have feathers on them. So this is all what can be put in my base class and let my bird being inheriting, right? So what we are saying is, if there is a specific bird that needs this class, so only the birds that want to fly should be able to have this feature. If the bird can fly, then only then it should be able to pass this object here, right? That means we need to check what type of bird is being there, and we need to pass that instance of the bird in my find class. uh, so what are we trying to say is, okay, let's see, we're trying to say that only uh, birds that can fly should have fly, right? So what we do is we need to check what kind of basically we need to check the instance of the bird. If it's a bird that can fly, then go ahead. If it's some bird which can fly, then okay, perfectly. Let that that thing should work. If it's a bird that cannot fly, so then that shouldn't be working, right? One way is doing this. The other way is basically we use polyfill prism. Instead of checking if a bird can fly at runtime, we can design our system so that only objects that can fly will be passed to the fly functions, right? That is nothing but what my but then okay. But then what are we risking here is, now what if we check the instance? So remember, when we check the instance, we are doing at runtime. That means there is a possibility at compile time we might have some we are checking this at runtime, right? But then we don't want this feature. We want everything to be clear right from the starting when we implement the code as well, right? So then what we do is basically we design our system in such a way that only objects that can fly will be passed to our fly method. So basically what we are going to do is, instead of having this thing, what we are saying is, um, define our fly class in such a way that only birds which can fly should be passed to the fly method. So this is a very neat and raw implementation, right, of what we are trying to do. So that is a very good way, right? So in the compile time itself, we are doing the checking instead of going to the runtime level checks. Okay, so this is basically what my Discord principle is going to say, right? I mean, this is the other way around, right? So if so what does Liskov substitution say? So there is some um, so when why it's mattering is because our so inheritance is on hierarchy, right? If that hierarchy is not formed properly, then um, um that hierarchy will be the correct behavior that is going to define, right? So subclasses should be usable anywhere the base class is used. Okay, so then so the other way, indirectly, what we are saying is um, yes, Liskov, there is some sort of substitution that happens. So in other words, what LSP is trying to say is if a base class had methods, it is having a behavior that a subclass cannot support. Then basically what we are saying is we are going to violate LSP. I guess Liskov is the name of a person. Looks like this. This looks like a mathematical concept to me. Liskov substitution. Yeah. Uh, so the duck dilemma. This is what the. This is a very good problem. Again, this is also like the same issue that we are having, right? Now, what if all ducks cannot quack, right? That means what he's trying to say is we should not have that. We are basically trying to solve that base class problem, right? Or in other words, what we are trying to say is okay. Now let's see this thing. In other words, how are we trying to solve that, or what that base class issue is? Now, what is happened is here we have the instance of class being sent, right? Now, what if we try to call okay, I can see what is trying to do here. Now, as the instance is present here, right? We have the instance being passed in. We have the instance present here, right? As the instance is already present, then we can call this um, ostrich class to make it fly, right? We can call this thing to make the ostrich class fly, but then this is not correct, right? Although it is expecting a bird instance, but the bird instance is already present here. Okay, so what we can do is, so this is like an instance method which is being passed, right? The moment we create an object of this, so we have access to that. So, oh, I guess what is it? So the moment we do new ostrich, we will have to pass the bird instance inside as well, right? So now this function call now makes sense. So even though we are going to call bird.fly method, so now since that is an instance variable, you can still have this thing being present here, right? So using the ostrich class itself, we can call the fly method on the bird, on that specific bird. This method needs a bird instance, right? So even though we have passed it over here, but then this doesn't make sense, right? Uh, oh no, this is going to be my bird instance. And then I'm going to call the ostrich. We can pass an ostrich where a bird is expected. So here we are so okay. Make it flash. This is our method. So we need a bird, right? So we can pass this ostrich over here because of that instance being present. This is an instance. Okay, so we are overriding this itself. I see what's happening. But ostrich dot fly is not making sense. That is wrong, right? It shouldn't happen that way. Oh, so basically we are yeah, it's the same thing, right? Because of that phi class being present in the base is the issue. That is what is happening, right? If the fly method wouldn't be there, then the even we would have plus. So this is basically a way to check of what's happening. I feel Liskov substitution is in it should be a math problem. I think so. Okay, the Liskov substitution principle defines a subtopping relation called a strong behavior. Uh, she's the one who introduced the Liskov substitution. I feel it's still a uh, yeah, the Liskov substitution is coming from her. So basically, that is how we can check, right? If you pass the instance and then you call the same method again, this could be called now because we have the instance already been passed here. Yeah, so that is a way to check. So, if in simple terms, what we are trying to solve is the base class problem, right? So, what Liskov substitution solves? Liskov substitution um is solving the base class problem. Like it's meant to uh, solve that issue. Okay. Now the next in we have is ice. Is we have interface segregation, right? The next alphabet that we have in solid is I, right? Basically, that's a um, we have to do is interface segregation. That means we shouldn't be using or oh, so basically what is saying that don't have all the interfaces. Like interface is like a contract, right? In OOP. So whatever class is going to implement it, all that. So even interface is bad. If you think interface were good, no. So what segregation means we split. Okay, this is more like is this not single responsibility? Oh, but single responsibility is related to a class, right? An interface is not a class. The class will be implementing an interface or a contract, mandatory thing. Oh, I see. The inheritance, we don't have that mandatory behavior, right? They may or may not override, but then the methods are directly inherited, right? Although This is this that war that goes with interface and inheritance, right? Now, when we do an interface, we are only inheriting the structure. We are not inheriting the behavior and the structure. Sorry, we are not having both the behavior and the inheritance and the structure present, right? That means by what he is trying to say is the structure is the code present inside. I mean, behavior is the class functionality. So behavior is the class, the function functionality, right? And the structure is it the signature? Yeah, basically what we are going to do in inheritance, we are going to have both the functionality um, and the structure being inherited. Right? We don't want both of them to come in. Instead, we suppose if we want only so then we will have to do overriding a lot, right, in inheritance. But then what if we only have to use an interface or only have this structure, and then that structure implementation can be done by the contract who is going to so inheritance is not good. So basically instead of inheritance we prefer interface, but then it doesn't make too sense to have write all the interfaces. Then interface is not a class, so the single responsibility is not what we are talking about. Instead, there is a way to check if the interface written is a proper way, right? So that is what my interference segregation does. So interface segregation says is you don't have all the interfaces in one interface. Like you don't have all the contracts in a single interface. Segregation is to separate, right? So this is segregate your waste. That means basically separate your waste as dry waste, wet waste, and recyclable. So segregation basically means segregation is basically separating, right? That means in an interface, don't define all contracts in single interface. So that is what interface segregation is. And next we have D is dependency inversion, right? So this is when we are passing like dependency or D in solid principle, right? Now dependency inversion principle basically means that when we are dependent on another class or a module, we should not be the higher level module should not be dependent on the lower modules, which will be on abstractions, right? So abstractions Like why is this problem happening in the first place itself? Oh, okay. This is when we are performing nesting of objects, right? I guess this is more dealing with nesting objects. Nesting, like nesting objects, or creating an object inside the another. Yeah, that is when you generate a dependency, right? Yeah, that is what we are dealing when we have a nested objects. For example, when we are creating the object of a class inside another object. So that is a problem, right? We shouldn't be doing that because if suppose okay, yes, that means if we have a car, so this is, let's assume that this is our car, and inside that, let's assume that this is our engine, right? So if this car is being created here, right? Uh, if this is my car, and then this is my engine, right? So this engine is nested inside the car. So that means to create this object, the outer object needs to be created. So this is not a very good way of writing code. So what if we need to add some additional functionality to this engine? Like we need to add a specific type of engine, for example, V8. Uh, okay. How is open close getting violated though? Oh, but the moment we have that instance present, we can modify, right? Should be open, yeah. The moment we have that um, instance, the modification can be done, right? Yes, that is the problem. So open close principle again says that we shouldn't be able to do that. Shouldn't be able to modify it. Instead, we should be able to extend it, and then overriding is what. Okay, so open close. Uh, yeah, it basically uses extending via inheritance or composition, and method overriding is a common way to do. So instead of modifying the code, we don't want to modify the code. Code written is written. We don't want to change it. Else, why would we write it? Yeah. One of the ways is overriding, but then we said that inheritance is bad, right? Because of that base class issue. So if we are writing inheritance, that means we should make sure that we are not falling into the base class trap. Because the moment we fall into that base class trap, then we are gone. Okay, so yeah, that's all for the structure. I'll see you guys with not now we have studied the solid pattern. So we'll see a code where the and try to understand which principle is getting violated where, and then we'll see some like readily available pattern that's are already been designed to solve to follow the solid principles in certain scenarios. We'll see that. So that's all for this lecture. I'll see you guys in the next one. Till that time, take care. Bye bye.